Let's suppose that capital X is some continuous random variable and we know its probability distribution function. Suppose that the probability distribution function is given by this f of x here. We don't know what h is, right? That's still an unknown. We want to choose h or scale this function such that this is a valid PDF. Valid PDF means that it integrates to 1 over the whole domain, right? So we've got a restriction on our values of little x, so we just have to compute an integral and force f to be normalized to 1, right? So normalized so that the integral of f is 1. The next two parts of the question demand that we find the expectation and the standard deviation. So this v is the variance, square root of the variance is the standard deviation. All right, let's get cracking. For A, we want to force h 1 minus x dx between 0 and 1. That thing had better integrate to be 1, such that this is a valid PDF. So we've just got to integrate a polynomial. H is a constant, so it can come out. X minus x squared dx equals 1 over h. When we integrate this, we get x squared on 2 minus x cubed on 3 between 0 and 1 equals 1 over h. This means we get 1 over 2 minus 1 over 3 at the top limit. The bottom limit just gives us 0, so that's equal to 1 over h. So this gives us 1/6. And then we can just turn this on its head and we get h equals 6, right? So for it to be a valid PDF, we need that to be true. Okay. Oh, and we've got limits on x. We now want the expectation of capital X. So this is for part B. So we remember the expectation is like the mean, if you like. It's a geometric measure of center. It's given by an integral. And again, the integrals over all of the domain. It's x times the distribution, dx. So that's equal to 6x squared 1 minus x dx integral over 0 to 1. Right. Again, this is just integrating a polynomial. That's going to give me an x cubed over 3 minus x 4 over 4 evaluated between 0 and 1. So that's 6. The bottom limit obviously gives us 0. Still, the top limit is a third minus a fourth, which is a 12th. So this turns out to give us a half. The variance is a bit trickier. We have to remember that the variance is the expectation of the square minus the square of the expectation. That's the easiest way to calculate it usually. So we know this bit already, right? We know the expectation, we can square it, we get 1/4. We have to work out e of x squared, which is the second raw moment. So we know that this is given by the following integral. So e x squared f x dx so that's 6 integral 0 to 1 x cubed now, I think, minus x fourth when you plug in what f of x is, dx. Again, we're just integrating polynomials, so I'm just going to save you the hassle of working this out. You're going to get 3/10. So when you plug into this formula up here, you get the variance of x equals 3/10 minus 1/4, which you'll find is the common denominator here is 20. So you got 6 minus 5 over 20. So you get 1/20th. So the standard deviation is 1 over square root 20.